Good afternoon, class. Welcome. What we'll be working on today is linear programming problems. You know, last week we dealt with a linear inequality system of equation with linear inequality. And what we'll be doing this week is that we'll be using those kinds of inequality to solve problem in linear programming. Because on the variables that we have, there are certain restrictions that are being placed. We call them constraints. And for us to define those constraints, we'll have to use linear inequality, those symbols. So, linear programming, it provides a way to solve problem in which the quantities that are to be maximized or minimized are limited by other factors. And those factors are going to be given in the problem. So then, what we'll have to do is that we'll have to write an objective function. You can use any variable, probably z or so on. And using what this objective function is, it's an algebraic expression in two or more variables describing the quantities we want to maximize or minimize. So we have a problem here on board. So let me read this problem. It says a student earns $10 per hour as a cashier and $12 per hour as a babysitter. And in the problem, they said that x equal to the number of hours worked each week as a cashier and y equal to the number of hours worked as a babysitter. Our problem here would be to write an objective function that describes the student's total weekly earning. Now we know the amount paid per hour as a cashier and amount paid per hour as babysitter. But we don't know the amount of hour work. There would be certain restriction placed here. So we can go ahead and write our objective function. And we can use z, you can use any other letter if you want. Or I would say z is equal to 10 times x, x is the number of hours worked as a cashier, plus 12 times y, because y is the number of hours worked as a babysitter, and the student is paid $12 per hour as a babysitter. So this z equal to 10x plus 12y uniquely describe that situation, and that is our objective function. Z equal to 10x plus 12y. Now the student is subjected to certain constraint, because this constraint is placed on the number of hours the student can work. And let's see what those constraints are and use our knowledge of inequality to define mathematically those situations. It's stated in the problem that you have that the student is bound by the following constraint. To have enough time for study, the student can work no more than 25 hours per week. No more than 25 hours per week. And in many situations that is so. So how can we define that then? We need to write a linear inequality, an equation for that situation. So then we know that it's going to be x, the number of hours worked as a cashier, plus y, the number of hours worked as a babysitter, must be less than or equal to 25. So there you go, one of the constraints has been defined here. Everybody on board? Everybody understand what we're doing here? All right? So we finish one of them. Let's look at the other constraint. It says that the store requires a minimum of 8 hours per week as a cashier. So the student now working as a cashier, but the store owner says that the student must work at least 8 hours per week. That's another constraint. So then we'll have to write an inequality for that. the number of hours the student can work as a cashier would have to be more than 8. So x here must be greater than or equal to 8. And that uniquely defines that situation. Everybody agree with that? All right. Let's go on to the other one. There's another constraint here, which is on your other page that you have there. And it says that the student can only work a maximum of 16 hours per week as a babysitter. So the student can only work a maximum of 16 hours per week as a babysitter. So y must be less than or equal to 16. And this also defines that situation with an inequality. So we have 3 equations there with inequality, and these are our constraints. These are the constraints in this problem, constraints. Now, to graph those equations, we have to rewrite them without the inequality symbol, and we'll replace those with equal, because to draw the graph for each one of those equations, we have to use the equal sign. So that's what we'll be graphing. So we'll be graphing x plus y equal to 25, x equal to 8, y equal to 16. We can rewrite this top equation, x plus y equal to 25, in slope-intercept form, in which case y is equal to minus x plus 25. Y equal to minus x plus 25 would give you an understanding, since we already did slope of a line, of where that line crosses the y-axis, the y-intercept, which would be the 25 at the back there, and it has a slope of -1, meaning to say it's sloped downward. So if you look here at this diagram here, this 25 here is where this line crosses the y-axis, and this line comes down. Now, to find where it crosses the x-axis, at 25 it crosses the y-axis. This is the y-intercept, and then our equation is x plus y equal to 25 after we take out the inequality symbol. So we can set y equal to 0 and find the x-intercept. So if y equal to 0, then x equal to 25, and it crosses the y-axis, the x-axis here. So then, this is one point, which is x equal to 25, y equal to 0. All right. Now let's go ahead and graph. So we have the line here, y equal to minus 25 minus x plus 25. Now let's go ahead and graph the other one, and that would be x equal to 8. X equal to 8 is going to be this line here, and it touches that line, y equal to minus x plus 25 at that point there. Now, let's graph the other one, y equal to 16. So y equal to 16 is between 10 and 20 here, and if we go across, right across, you see it touches this line at this point here where y is 16. But to find the x value, then we can do this. We know x plus y is equal to 25, and if y is 16, then x plus 16 is equal to 25, and then x is going to be equal to 25 minus 16, and this is 9. So at this point here on this line, y equal to x plus y equal to 25, when x is 9, y is 16. So this is another point. There's a little space here. All right. So we have two vortices already, and the other one of concern we'll use will be this one here. X equal to 9, y equal to 0. So those are our three vortices. Our vortices are x equal to 9, y equal to 0, x equal to 25, y equal to 0, x equal to 9, y equal to 16. So now, the problem says, graph the system of inequalities. Since you cannot work negative hour, look only in the first quadrant. So here we are in the first quadrant. And it says here, to evaluate the objective function z equal to 10x plus 12y for function for total weekly earning, and analyze hours work to maximize the number of hours worked to maximize the weekly earning. So what we'll be doing here, we'll evaluate the function, the objective function, for total weekly earnings and analyze how many hours to work to which the weekly earning will be maximized. So let's look at this then. What we need to do is to find the value of the objective function at these vertices, and we are looking for the maximum value. Which one of those three vertices will give us the maximum value? So let's go ahead and do that. So then, our z here is going to be equal to 10 times 9, because x is 9, plus 12 times 0, because y is 0, because this is our objective function, z equal to 10x plus 12y, and this is going to give us 90. This is going to give us $90. Because when we substitute the value for x here, which is the hours, and we multiply by the earning, $10 per hour, we get $90. So that one is $90. So let's go ahead and evaluate the objective function at this vertex here, at x equal to 25, y equal to 0. So then z is going to be equal to 10 times 25 plus 12 times 0. So there we are multiplying 25 times 10, $10 per hour as a cashier. So this is going to give us 10 times 25, $250. Because 12 times 0 is 0. So then, that vertex there give us $250. And let's go ahead and evaluate this objective function at this vertex here. When x is 9 and y is 16, which means to say that when the student worked 9 hours as a cashier and 16 hours as a babysitter. So that's what we're going to be doing here. So then this is going to give us z equal to 10 times 9 plus 12 times 16, and this is going to give us 90 plus 12 times 16, 72, 7, 19. So this gives us 90 plus 192. Give us 2 here, 18, 112, and this gives us $282. So then, student, if you look at that calculation there, we find that this vertex here, when x is 9, y is 16, this is when this objective function assumes a maximum value of $282. And that is what we're supposed to find here. Evaluate the objective function for total weekly earning, analyze hours work at which the earning is maximized, the weekly earning. So this would be the solution to the problem. 282, using what we call linear programming and defining an objective function and taking into consideration the constraint placed on the student. The student maximum earning would be $282 when that student worked 9 hours as a cashier and 16 hours as a babysitter. Then the student will obtain the maximum earning. So this is a lot of information here, and this is an application problem using objective function and linear programming. So you'll be doing a whole lot more of this, and you'll get an understanding. These kind of problems, they're very important. In many cases, many of the items are subjected to constraint, like in disaster area and so on, logistics and supplying of foods and so on. There are constraints that are being placed on what can happen, what you can do, and these kind of problems are being solved by defining and using inequality to define a variable. So we'll talk more about this later on. I want to make sure everybody understands the problem. Any question? All right, so make sure you complete your problem, and I will come around and check those and see